In the previous videos, we had looked at what happens when we take factors that are like each other, like x plus 2 times x minus 2. We should know by now that that gives us, when we multiply them out, we get the difference of squares. And conversely, if I have the difference of squares, I could turn around and factor it into x plus 2 and x minus 2. So we can go either way, depending on what the directions are. We can either distribute the factors, or we can factor the difference of squares. Likewise, if I had x plus 2 squared, which would be the same as x plus 2 times x plus 2, we get a perfect square of x squared plus 4x plus 4. Once again, distributing the two binomial factors will give me the perfect square, or taking the perfect square, I can turn around and factor it and get the original factors back again. So I can go either way. So we learned to factor by looking at what would happen when we distribute certain kinds of patterns. So let's look at a new pattern here. What happens when the integers aren't the same? So, for example, what would happen if I took the quantity x minus 3 times the quantity x plus 5? So the first one has the integer 3 and the second factor has an integer of 5. Obviously, distributing them is no harder. When we take our first terms, we end up with x squared. The second term, first term times the second term will end up giving me a plus 5x. When I take the second term of the first factor times the first term of the second factor, I end up with minus 3x. And finally, when I take the minus 3 times the plus 5, I will end up with a product of negative 15. So you can distribute that, and you don't have to show all of the arrows. What gets complicated, though, is that the middle terms will usually end up being combined. So if I look at this, I will end up losing information, because I will get a result of x squared plus 2x minus 15. So the 2x doesn't give me as much information as the plus 5x and the minus 3x. So it's very easy to go in the forward direction of taking the factors and distributing them and combining like terms. It actually becomes quite difficult to go backwards in the other direction. And so we want to give you a few techniques for doing that. But first, let's establish a pattern so that we can, it'll make more sense of how we can do that. So let's look at a second example, and we won't show quite as much detail. In this one, let's consider x plus 3 times x plus 5. So very similar example. When we multiply out all of the terms of the first times the terms of the second, we end up with x squared plus 5x plus 3x plus 15. So we end up this time with x squared. When we combine the middle terms of 5x and 3x, we get plus 8x plus 15. Okay, so we can look at these two examples and see a pattern. Okay, first of all, the first example had one minus sign and one plus sign in the two terms, whereas the second example had two positive signs. So you'll notice what happens when we multiply negative 3 times 5, we ended up with a negative 15. Whereas when we multiply a positive 3 times a positive 5, we get a plus 15. A negative 3 times a negative 5 would give me the same result. So if I wanted to refactor this, I could, I would know that if I have a minus here, on the final term, we must have different signs. If I have a plus term, the two factors must have the same sign. Other things that you might notice is we had 3 and 5. And when we look at the first example, we get a 2 as the number, and you could think of it as positive 2 in this case. we get a positive 2 as the coefficient on the x term. Well, that's exactly the difference between negative 3 and 5. In the second example, we got a positive 8 on the middle term, which is the sum of the 3 and 5. If we go back and look at the original expansion with all of the terms, it makes sense why that happens. In the first case, we had 5x minus 3x when we expanded, and in the second case, we had a 5x plus 3x, which gave us the 8x. So the middle term that we have in the on the far right must be the result of either a sum or difference. Notice when it was different signs, it must be the result of a difference, and when it was the same sign, it was the result of a sum. If we ended up having a double negative, the middle term would be negative. We could still have the same sign with two negatives, making the middle term a negative term, but we would be adding up two negative terms, not finding the difference between a positive and a negative term. So let's consider how to use this information to go onward. Let me give you some examples where we will try to now factor them. Let's clear this out. Let's consider the example x squared minus x minus 2. So to figure this out, we can first of all write out that we're going to have two binomials. So we'll write out the parentheses. We know that the product of the first terms will be x squared, so x and x must be our first terms. Now let's consider all of the possible integers that could be multiplied to get 2. The only possibilities are 1 and 2. So we can right away write in that we must have a 1 and we must have a 2. Now, looking at this, we know that we have to get a negative 2. So one of the terms must be, one of the factors must have a plus sign in the middle, and one of the factors must have a minus sign in the middle. And we need to figure out which way to go. So when you look at the middle term of the original expression, we get a minus x. So in other words, the overall result is we have to subtract more than we add. And the only way we can make that happen is to subtract 2 in the second factor and add 1 in the first factor. And by the way, you could have just as easily have started this by reversing the order. So that would be the same factoring of the original expression. Let's go to another example. Let's consider x squared plus 7x plus 12. Once again, we're only considering cases in this video where we have one x squared. So once again, we know that we must have an x and an x for the first terms of each factor. Now we have to consider the possibilities. This one's going to be a little bit more complicated. 12 could be 1 and 12. When you look at 1 and 12, though, there is no way to add 1 and 12 to get 7. And there's no way to subtract 1 and 12 to get 7 either. And the other thing that's happening here is we know that it has to come out to a positive 12. So we either need to have 2 plus signs or 2 minus signs in the factors. Given that it's plus 7x, I know that we must have a plus sign in both factors. So adding 1 and 12 gives me 13 and not 7. But we can factor that in different ways. We could have factored it into 2 and 6. Okay. 2 and 6 do not add to give me 7. So I can keep going. Notice the first factor is getting bigger, so I go to 3 and 4. And lo and behold, 3 plus 4 is 7. So if I write a 3 there and a 4, they're interchangeable since it's both terms are terms of addition. And so if I write those in, I will have the correct factoring of the original expression. You can always check your work by re-expanding it. And the tricky terms are always the middle terms. And I'm going to have a 3x and a 4x, which will add up to 7x. And the 3 times the 4 will give me a 12. Let's consider just 2 more examples. So let's consider the example x squared minus 13x plus 36. Okay. So if we want to factor this, once again, we know we have to have an x as the first term of each factor. This time, let's consider the signs. We need to get a positive 36, so we either have to have a plus plus or minus minus. Given that we're getting negative 13x for the middle term, or we're given that, we know that we better be doing some subtracting. So this will be a minus minus case in order to get it to work. Okay. So now we need to get the integer terms that we can fill in, and they need to have a product of 36, which is exactly why we look at the possible factors of 36. You always start with 1 and the number, but clearly if we put those in there, negative 1 and negative 36 won't give me 13, so we keep going. We have the possibility of 2 and 18, but negative 2 and negative 18 would be negative 20. We can look at 3 and 12. That still doesn't work because we'll end up with a negative 15 when we do that. Okay, so we can keep on going. Let's consider, I notice I keep going up with my first factor. 4 times 9 is also a possibility. And when we go there, we look at that, and a negative 4 and a negative 9 would give me negative 13. So I can fill in negative 4 and negative 9. Once again, since both terms are subtractions, the two terms are interchangeable. I can put the 9 and the 4 in reverse order, and I'll have the same result because of the commutative property of multiplication. So this one worked out nicely. You can distribute and get x squared minus 4x minus 9x and a minus 36 when you multiply it out, which agrees with the original expression. So you can always check it real quickly if you're not fully confident in your answer. Just one more thing to note here. I could have kept going if 4 and 9 didn't work. I could have considered 5, which doesn't work, but I could have considered 6 times 6. In this case, 6 times 6 wouldn't work because we would have to end up with a 12 if we took the negative of both of those and added them. We don't go beyond this, though. This is the exhaustive list of possibilities. Once the second factor is as large as the first factor, if we were to keep going, the first factor would keep growing, and the next thing that would work would be 9 and 4. But 9 and 4 is the same as 4 and 9, so we stop before we get there. I'm going to give one final example to show that while this method is wonderful when it works, and our method here is to look at the factors of the last term, the constant term. This method is wonderful when it works. It does not always work. So let's look at a case where it does not work. Very similar to the last case, but I've changed the middle term to be a 10. So just like in the last case, we would have to have x minus something times x minus something if this were going to work. But when we start writing out the factors of 36, we know we would have to have a subtraction of both of them, so that would result in a negative 37x for the middle term. If we go with 2 and 18, that would give me a negative 20 as the middle term. 3 and 12 would give me negative 15 as the middle term. Then we could keep going. 4 and 9 would give me negative 13, which we had in the last example. 6 and 6 is the last thing that we can try, and that gives me negative 12. So none of these work. And we've exhausted the list of possibilities. We don't go beyond the 6 and 6. So this expression, x squared minus 10x plus 36, does not factor by using the method we're looking at, where we simply look at the factors of the last term. So while this method works nicely for a lot of examples, if you were to randomly write out quadratic expressions, it will more often than not fail.